Everyone. My name is Tejesh, and I'm an incoming freshman student at the University of Minnesota in Twin Cities. And my demo today will be about a scanner that displays whether or not a given user MRI scan has a tumor or not. So essentially what I did, can everyone see my screen?
Yep.
So essentially what I did was that I used aspects of the LANet architecture to build, train, and test my convolutional neural network. And so there are four main operations occurring in the back end of this network. The first main operation is convolution. And the primary purpose of convolution is to extract features from the input image, which is represented by a matrix of pixel values. It preserves the spatial relationship between pixels by learning image features using small squares of input data. And in doing so, it captures the local dependencies of the input image and it generates different feature maps from the same original image. And then the neural network learns the values of these filters during the training process. And the second main operation is nonlinearity. And to do this, I used the ReLU activation key to introduce nonlinearity, which takes a real valued input and thresholds it at 0, replacing negative values with 0. So it works perfectly with this use case, as we want our accuracy to be between 0 and 100%. And then the third main operation occurring in the back end is the pooling, which reduces the dimensionality while retaining the most important information within the images. And so I wanted to define a spatial neighborhood, so I used max pooling in 2 dimensions and normalized the dimensionality of my dataset to ensure increased accuracy. And in doing so, I was able to progressively reduce the spatial size of the input representation and make the input representations more manageable. And this also helped me avoid overfitting and ensure that the neural network was invariant to distortions. And then the fourth and final backend operation that's occurring is classification, or a fully connected layer. And so to achieve this, I applied a traditional multi-layer perceptron that uses a softmax activation function in the output layer to connect all the neurons in the network. And the output from these neurons and layers represent like high-level features of the input image. And it uses these features for classifying the input image into various classes based on the training data set. And so a demo of a working model is I used Streamlit to visualize this. So I basically created a file uploader on Streamlit, and one can browse their files, and let's just pick a random example. And then so this one clearly has a tumor, and then so once you upload the image, it classifies it and it tells you whether or not your scan contains a tumor. And the same thing goes for say anything that doesn't have a tumor. So we could pick a random one. And this one, yeah, as you can see, it says there is no visible tumor in your MRI scan.